Good morning to one and all. Today we are going to discuss energy resources here. These are the contents we have to cover in this particular session. Conventional and non-conventional energy resources. Layout of different power plants here. Hydel, nuclear, solar, wind power generation. Yeah. And the main classification of sources of energy here is conventional sources, non-conventional sources. These are the different sources of energy, conventional, non-conventional. In conventional sources, we are having some commercial, non-commercial. In terms of commercial, we are having some coal, oil, thermal. Whereas in non-conventional, we are having some firewood, hydro, nuclear. In terms of non-conventional, solar, wind, tidal, geothermal, biomass energy. The conventional sources of energy are generally non-renewable sources of energy, which are being used since a long time there. Conventional sources is nothing but coal, oil, thermal, firewood, hydro, nuclear. The brief overview of this conventional sources here is, let it be, I'd like to go for the part of coal. Coal is the important source of energy there. We are having some 1,48,790 coal deposits up to 2006, and we are having some, it went up to million tons there. India is the fourth largest coal producing country, and we have some so much of deposits in Bihar, Orissa, Madhya Pradesh, Jharkhand, and Bengal. In a similar fashion, oil and natural gas is liquid gold, and oil is primarily used in planes, automobiles, trains, and ships. And we have oil production in India is 0.3 million tons in between 1950 to 51, which is increased up to the level of 32.4 million tons. Right now, it is above 50 million tons is there. It is mainly found in Assam, Gujarat, and Mumbai. Thermal power plant is generated at various power stations using oil and coal. It is vital sources of electrical power. Hydroelectric power plant is produced by constructing dams above flowing rivers there. Nuclear power, the fuel used in nuclear power plants is uranium or plutonium, which costs less than coal. Nuclear power plants can be found in Kaiga, Kota, Aurora, and Kalpakam. Non-conventional sources of energy, mainly solar, wind, tidal. Solar is produced by the sunlight. The photovoltaic cells are exposed to sunlight based on form of electricity that needs to be produced. And wind energy is generated by harnessing the power of wind and mostly used in operating water pumps for irrigation purpose. India stands as the second largest country in the generation of wind power. Tidal energy. Tidal energy is generated by exploiting the tidal waves of the sea. The source is yet to be tapped due to the lack of cost-effective technology, which is to be elevated on the tides in the oceans. Now, that's a typical one. The main classification of conventional sources and non-conventional sources. The sources of energy which are in use from the past are called as conventional. Non-conventional in the sense which are in use only from the recent times and termed as non-conventional. These sources are exhaustible. Don't forget that line. Conventional is exhaustible in nature. These sources are inexhaustible in nature. And the examples of coal, petroleum, natural gas, electricity, etc. are some of the examples of conventional sources of energy. Tidal, wind, solar are some of the examples of non-conventional sources of energy. These sources are polluting the environment. And don't forget that line. Exhaustible, and it pollutes the environment. These sources do not pollute the environment and can be said that eco-friendly sources. Coming to the part of hydroelectric power plant, this one is a layout. Observe this particular layout here. The main intention of hydroelectric power plant here is we can generate some electricity with the help of water. That too, I can have some main parts here is reservoir, dam, we are having some surge tank, wall house, power station, and the tailors. In this particular one, the dam is located here in order to flow this particular water from the high range to the part of this turbine. Inside the power station, the layout may be like this. Observe this one. We are having some head of the water now, and we constructed dam here. The level of this water is flowing through the parts of one pipeline here. That pipeline may be called it as penstock, and we can split that particular water through the penstock onto the turbine rotating blades. Inside the turbine, we are having some rotating blades, and it can rotate, and we can extract some mechanical energy. That mechanical energy is coupled to the part of generator, and we can extract some sort of electrical power, and we can store in control dome, and it can step up to the level of high voltages here in order to match the grid voltage. for the transmission purpose. And we can observe one more part here. This penstock is nothing but it's a large pipeline here which can transfer water from dam to the part of turbine rotating blades. In order to make this protection of this penstock, we can use some such tank there. Such tank can store some water in order to protect these penstocks. If we can flow some excess amount of water directly onto these penstocks, these pipes will burst out there. In order to store that excess water, we can have some such tanks. These are the main parts, and we can have some the remaining water. All the water doesn't split on the turbine. Some amount of water will waste out now. That water is come to the part of tail water too, and we can use it for the part of other purposes. This one is the general layout of the part of hydroelectric power generation, which extract electricity from the water. These are the different description wise. We can call it as dam or wire, which can store energy. In a similar fashion, we'd like to go for the part of nuclear power plants here. This one is a layout of a nuclear power plant. In this particular nuclear power plant, the main part here is this one, nuclear reactor. Don't forget this one, nuclear reactor. And the main parts inside this nuclear reactor is fuel rods, control rods, moderator. The fuel rods is nothing but it's a nuclear fuel. Let it be, we can choose some uranium or plutonium, uranium 235 or plutonium 239. And we can have some control rods here, which is made up of boron or cadmium, which absorbs the neutrons and control that fission reaction. We can have some moderator here. We can use as water, heavy water or graphite, which slows down the neutron. Yeah, observe one thing here. Inside the part of this nuclear reactor, we can observe some reaction there. That reaction is nothing but nuclear fission. What's that nuclear fission is nothing but a fast acting neutron will bombard the part of uranium fuel. Then we can split it out some barium and krypton here, and we can liberate it out some high amount of heat energy. That high amount of heat energy is approximately 200 million electron volts. That high amount of heat energy is passed via the part of pressurizer. Inside the part of this one here, we are pour some water. When I can extract some heat energy here, inside the part of this water will boil out and we can extract some sort of steam. That steam is splitting on the part of turbine rotating blades. And there it can rotate there, we can extract some mechanical energy. That mechanical energy is coupled to the part of alternator or AC generator. We can extract some electrical power, three-phase power. And when high amount of steam is splitted on the part of turbine blades here, some amount of water is wasted out and we can again recycle that one via the part of some condenser. And we can recycle that one. That it is that water, again it's split down to the part of cooling tower and it recycles the part and it can bring back again to this pour into this water. We can use it recycling the part due to the part of Rankine cycle like this. And the coolant material we can use it here as carbon dioxide or water. This one is a structure of nuclear power plant and this one is a layout. This one, nuclear reactor, heat exchanger, which can extract some steam. That steam will ventilate onto turbine blades and it can extract some mechanical energy is coupled to alternator and we can extract some electricity there. It is given to step up transformers via the isolators and given to the part of household. Some amount of water is again back to the part of condenser, cooling tower, and some is given to the part of from the river. We can choose it some water inside the cooling tower. It can recycle that steam. Again, it converts that steam to the part of water droplets. Again, it pour into the river. It's a recycle. Yeah, this one is it. This one is a description, brief description of nuclear power plant. And the next one here is layout of solar power plant here. And we already know that solar power plant, which converts directly sunlight to the part of electrical energy. In this solar power plant, our main part here is solar PV panels or array. What's that? PV is nothing but photovoltaic panels here or solar panels. Inside that part of PV, photovoltaic cells made up of semiconductor material, which is frequently mostly used as silicon here. That sunlight, whatever may be sunlight here, will ventilate on this particular PV panel. It converts that particular thing into DC electricity there. DC electricity, this one. That one is positive negative stands for DC, direct current. The direct current is again converted into AC by placing some inverter here. Inverter is a device which converts DC to AC. Then we can give it to some gearbox or household sockets here. And we can choose that efficient transmission here. We can step up that voltage via the part of some transformer in order to match that grid voltage here for efficient transmission. This one. And we also remember one thing, they wrote some line here, array stands for multiple solar panels are connected together to form some array. That's the only thing, one simple thing. Sunlight is converted into electrical energy. That's why photovoltaic panels are made up of semiconductor materials, mostly silicon. And the DC is converted to AC in order to transmit for the household purpose. That's a simple outline of solar power generation. Same thing. These are the brief description. And the next plant here is wind energy here or wind power plant. In the wind power plant, the main part here is we can easily observe the part here by harnessing the kinetic energy of wind. We have to write only one line, by harnessing the kinetic energy of wind. In that, we are having some rotor blades which captures the wind energy. Generally, we can use some 3 blades here. We can have some hub. We can observe this one also there. What's that hub is nothing but connects the rotor blades to the main shaft. We can have some nacelle here. Nacelle stands for which houses the main components of a gearbox, generator, and control system. Everything is inside the part of nacelle. Tower. This entire tower supports the nacelle and rotor blades, elevating them to capture the stronger winds at higher altitudes. This tower. And we can observe one more thing here. We can have some gearbox. No? It increases the rotational speed of a turbine shaft to match the generator requirements. That's the intention of having this gearbox. Only thing here, these turbine blades will rotate here. With the help of that wind energy, we can have some small amount of speed is there, 55 miles per hour, and that speed is increased via the part of this gearbox, and it can match this generator here. That gearbox will rotate now. Rotation is nothing but mechanical is coupled to generator. That generator will extract some electrical energy, and that electrical energy is a step up, and it can match the grid voltage levels. And in order to have this controlling that speed, everything will absorb the controller. Wind energy is converted to electrical. That's the only intention of this particular wind power plants layout here. And this one is outline here. The 2 turbines, wind turbines may be horizontal or vertical axis wind turbines. This one is outlined here. As the gearbox instead of is to transmit mechanical energy, these speeds are more suitable to the generator for the generation of electricity there. These are the outline of this particular wind power plant. Thank you very much.